Hi and welcome back. This is class 10 of this series of tutorial, and during this class we are going to talk about the colliders, how to build the colliders correctly and how to set them up inside the simulation. Okay, so before building our own collider, what I would like to do is to show you how Houdini is creating them by default with the shelf tool. So open a new Houdini or maybe create a new scene. Just create a sphere at the origin. Go with the PyroFX shelf tool below with smoke. All right. See the default setup here. Okay. Go up and then create a new geometry here. Go inside, create the rubber toy. I'm going to use it as a collider. Go one level up. Zoom out to visualize everything. And then here on the object, put it at distance of 4. Make it bigger. And this is what we have now. So then select it, go to the collision tab and click on static object. It's going to create for you a few nodes. Okay, so you go inside here. This is the nodes that have been created, sorry. And then inside here, you have a few other nodes. So if I press L to line up everything, these are the nodes that have been created and added to this setup. Okay, so here a collision source, which is outputting a geometry, and here a VDB. The VDB is cached, and here we have an attribute create. This attribute create is linked, okay, referenced rather into the dot network here, and you have it here, and it's really used to get the input of this node, and it's really the collision source 1. If you go to it, this is this one. All right. Back to the static object. This is the parameters we have. See that the use deforming object is unchecked. And so we are going to see the other way of creating it with the shelf tool. Go up here, go down, delete everything, go up. And I'm going to animate this. So on the rotate, I'm going to use $F and I'm going to multiply by 10. All right. So now this is actually turning. Okay. We don't have any collision yet because I didn't ask for it. So stop it. And now I select the geometry and I go here on deforming object. It's going to create the nodes for us again. And you go inside, you have exactly the same nodes. All right, exactly the same. But here you have the same nodes, but you have this which is activated. All right. And now if I go one level up and I press play, you see that we have the collision with the object. All right. So two ways of creating a collision with the smoke. Now it's exactly the same because we are actually using exactly the same setup. It's just in here we are defining whether this is a deforming geometry or not. All right. We have other ways. You could add a ground plane. You could add a terrain object, which is basically colliding with the height field, which are available into Houdini. This is not the case for us, so I'm going to focus on this for the moment. Okay, so back to our setup. And the first collider I'm going to work on is certainly the terrain. Okay, this is probably the most important right now. So I'm going to create a geometry, okay, that I'm going to call terrain collider. And I dive inside and I do an object merge. And well, you already done that, so terrain, merge terrain. Here you go to the terrain out. Don't forget to do that into this object so it uses all the transform. Now let's create a collision source. Okay, remember this collision source is creating a VDB. Okay, VDB, and it's creating as well geometry. So let's call that geo. All right. So we have these two things here, and we need to connect this. So now, if we look here, we have the geometry. If we look here, we have the VDB, and you see it's not working fine. To be able to create a proper volume, proper VDB, you need to have a closed geometry, and right now, well, it isn't. All right. So I'm going to close that, and the easiest way for this kind of situation is to come here and create an extrude volume. Okay, if you press Shift Enter, it's connected immediately behind it. And you just have to connect this one. All right, so the extrude volume by default is already doing what we want. Okay, you can increase the depth if you need, but that's fine for me. I'm going to use this. So we have this volume, and then it goes inside the collision source. And now if we look at the VDB, it should be fine. Okay, so what's happening with the... Okay, good. It's just a refreshing problem. That's it. And now, sorry, and now if you want to increase the quality of the volume, you can go here. You can reduce that to 0.5, and then you have a better volume. Or actually, if maybe it's too defined, then you can go for a 0.2. And so that's fine. So now, because this is a volume, we can cache this volume. So go to the wall emitter again, you know, then go to the terrain collider, paste this. Now we are going to cache the volume. So here I can convert it to 16-bit as well. All right, and then we read the volume back in, and then I don't need that. And this VDB is the one we are going to give to the smoke solver. All right, so here VDB, I'm going to visualize this, and there. And so here I can put that here. So we have this, and then we need to fix this. So this collider, the terrain, is really a static geometry, so we only need one frame. So I changed this, and then because it's a static, I'm going to cache it inside the static folder that we created. Here, because it's a static geometry, I don't have several frames, okay? So I can remove the folder and have only one file. And now if we check this terrain collider volume, no, it's a VDB. I want to keep it named correctly. And that's it. So now I can cache that, save to disk. Okay. Let's go to the static object to check that we have geo static, and now we have the terrain collider VDB. So if I go back here, now I should be able to, well, reload. It's already showing it. I can hide this. And so I have my collider correct. And now my collision volume is all set up. I can go inside my simulation network, and I'm going to create here a static object followed by a static solver, okay, followed by a merge. And I'm going to merge it inside my simulation. Then I'm going to put the output here, line up everything, and we are going to set up the static object. So here on the static object, I need to reference the subpass, and remember, we need on the static object, we need to reference the, where's the terrain collider? Here, we need to reference the collision source. Accept it. And here in the object pass, I need to reference the parent, okay? Just in case we need the transformation from the parent. Remember, here we have some transformation. In case we have some transformation, we want to have them here inside the simulation. Okay, now go to the collision tab, and the first thing we have is the collision detection. Here, if you use the solver default, it's going to use the smoke solver collision, and by default it's using volume, so this is fine. But just in case, if you want to force it to volume collision, you can do that. Now, here I'm going to come to the first frame, okay, because I need to be on the first frame to actually visualize all the change that I'm doing here, okay. If I do something here and I change, for instance, this, it's not going to display anything. We need to be here. Because this is a static object which is not deforming, it's not reevaluated every frame. So if I want to see something, I need to be at the first frame. And here I'm going to hide the display geometry. I'm going to show the collision guide, and this is what I have at the moment. So it's creating a collision guide for us with the ray intersect. It's creating it. It's not reading it. It's not reading the one that we created, and we really want to use the one that we created before because we cached it on the disk. All right. So to do that, you need to go here and go to volume sample. Now it's disappearing because you need to set the proxy volume, and here you go to the terrain collider and you define the VDB and you accept. Now it's taking some time to display, but now it's there. Okay. Now if I press play, so the simulation is working. It's actually simulating, but if we look here on the FPS, it's actually not a FPS, but FPM. Okay, it's frame per minute. We have 44 frames per minute. That's really long because we are displaying here the collision guide. And if we remove it, then we see we drop down to 3 frames per second. Okay, so I'm going to leave it play for a while, and then we are going to check if the collision is actually working. So if I go here, yes, here, and then we see that it's using really the shape of the terrain, so the collision is working properly. Now, I need to tell you a few things about the collision guide and how to control your collision. The default thing is the display geometry. Okay, so now you display the geometry that's been calculated on the first frame. Now you can display it anywhere you are. And this is really reading this geometry here. It's not colliding with this. It's just the geometry here. What is colliding with is the collision guide. And the collision guide is the one that we are referencing here, the proxy volume. Okay, so it's sourcing this one. So if you want to be sure that the collision geometry is good, activate the collision guide here and see if you don't have any holes, if it's the correct size, if it's defined correctly. That's the first step. But even though this one would be good, you need also to go on the smoke object here and to display the collision here, because this is what the solver is actually seeing for collision. This is what the smoke solver is really seeing for collision. Okay, it's not really seeing this collision guide. You can see it's really seeing the gray one, because it uses the fluid dynamic, so it's cropped by the fluid dynamic, and also it's using the resolution here, the division size here. If I reduce that, if I increase the division size, so I reduce the resolution, and now I go to frame 31, you will see that you have a less defined VDB. It's still okay, of course, but it's less defined than if I had the 0.1 here, and you see that now it matches better the one we have cached before. Okay, so really, if you want to see what is colliding, if you have any problem with the collision, you want to check not the display geometry, but this collision guide and this one to see actually what's happening inside your simulation. Now, I want to improve a bit more this terrain collider by using the wall static here. So I'm going to go back inside here. I'm going to merge this time the wall static and say here wall static and then out. That's good. Okay, into this object. That's fine. Let's check this. Okay, we have it. And so because we have this, then I'm going to do a merge. Okay, I don't want to extrude it, so I'm going to merge the extrude volume with this. I'm going to merge them. And now I'm going to put the collision source here. And now I'm going to line up this. Okay, no, I don't like this lineup. So this, there we go. So now if I cache that, let's actually visualize the VDB. It's taking some time to compute. If I cache that, then I have the fence also as a collider, which will be quite useful. And maybe I'm going to increase a little the resolution to 0.8, maybe. Okay, I don't really need it. So let's not clutter the memory. I'm going to cache that again, save to disk. And now we have this. I can get rid of this. This should update the collider inside the simulation. Let's go and see it. If I visualize the collision here. Okay, no, I need to refresh. Okay, so it's not refreshing correctly. So let's go back here, visualize this. And no, I need to reload the geometry. Yes, and now it should work. So if I go back here, I go back to frame 31. I have my cached geometry, my cached collider here working properly. And now the next collider I would like to work on is the wall simulation. I mean, the big fragments falling here. So for that, I'm going to duplicate the terrain collider because I have everything I need in there. And I'm going to call that wall sim dive. Delete the wall static because we don't need that. We don't need the merge and we don't need to extrude the fragments. Okay, they are already closed. So I'm going to say wall sim. Here I'm going to go fetch the wall sim out. Okay, let's check the animation. Okay, so it's fine. We have them, and now here the collision source is all set up. So I need to visualize my VDB, and this is the VDB. It's a bit coarse, so I'm going to reduce the voxel size even more, and this is the VDB we have now. So I need to cache. It's going to static. I'm lazy, so I'm going here, select this, and I'm going to select the expression, go back here, and set the expression correctly. Now if I display this, animated wall sim collider VDB, this is good. I'm going to render the entire frame range from frame 31 to frame 100. Save before, and save to disk. Good, so it's done. Let's visualize this, reload the geometry, we have it. All right, it's fine. We have this problem again, so time warp, should not have deleted it before. Time warp from frame 31 to frame 31, and now it's all good, working properly. All right, this is good. Then I want to go back to my simulation here. Okay, and so you have a static object. This is really, I should have named it. This is the terrain collider, and I want to duplicate this, okay, merge it with the first one, and I will call that wall sim collider. And now here you have to go to the not terrain collider, but wall sim collider. Select the collision source, accept. Here it should be the wall sim, okay, collider. All right, okay, sorry, and so we have the wall sim collider. I'm going to, okay, we have the collision here, that's good. And so I'm going to hide this one, disconnect this one for now. And I'm going to hide this. And we see if we have the wall sim collider correct. So volume sample here, we need to change as well. And if I go back here, now we have the collider. But you see, it's not moving. And it's because we need to activate the use deforming geometry. And now it's moving. And you can reevaluate the SOPs to interpolate the geometry. And now you have the fragments falling. But you see, it's not exactly the same definition as we had on our VDB. It's because here we have a lower resolution. So if I do, let's say 0.7, and now I need to go one frame further. Oh no, I need to rewind. So go back here and press play. Okay, so it's improving a bit, but it's still not the best. I think we put 0.2, but it's going to be too low for us. So this is a good illustration of what I was telling you, where the division size here is really influencing as well the sampling on this on the actual collision. Okay, because if we display the collision guide, then you can see, hide this, you can see we have a proper collision volume here, but it's not this one which is used, it's really the one which is sampled by the solver, and this is the one. Okay, so you might have some holes, you might have not really exact, precise collision. Now, in my case, I don't really care because it's quite far, okay? So I'm not going to use that. Okay, I'm not going to use a wall simulation collider because it's going to take some time to compute. and I'm not going to really see if the smoke is going inside or not the fragment. Okay, so I'm going to disconnect this and I'm going to use the terrain collider only. All right, and I can leave it here for you if you need, so you have it in the file. But I really am going to use the terrain collider only. I leave it up to you for your file. In case you have some hero collisions, then you want to use this, and then you need to obviously increase the resolution to make it work fine. And that's it for the collision. There, I think I talked about everything. So we're good with this. Just one last thing. Go to the top network here, dive inside. We are going to create one for the collider as well, because just in case we need to recreate, and it's a good exercise anyway. So wall collider emitter. Here I'm going to use VDB because I'm really grabbing the VDB. Okay, so why is it not VDB wall? Oh, sorry, it's wall sim. It's wall sim collider. All right. Okay, now it's good, and I can go here, which is fine, and then here, connect it here, and here if you do generate the node, it's fine. And if I press Shift G, save. Okay, it's all there because I already cached it when I was inside here. Okay, good. All right, so this concludes this class 10 about the collisions. Maybe I should add one more thing as a reminder. Computing collisions or using collisions inside the simulation really takes some time, okay? So you might want to disable the collisions while you're still tweaking the simulation and use the collisions only at the end, okay? Unless obviously you want to check the collisions are working properly and you are tweaking the parameters to improve the collisions inside. But otherwise, I recommend you actually disconnect here and work only with this as a simulation so it goes faster and you have some faster turnaround. All right. Otherwise, well, nothing more. Thank you for watching this class, and I see you in the next one. Goodbye.